Hey everyone, so my name is Zach Vines, and what we're going to go over today is dealing with discrete probabilities versus cumulative probabilities, and then we're going to segue that into how you can solve for certain probabilities using certain Excel functions. So to kind of start off with, I want to talk about what a discrete probability is versus a cumulative probability. So discrete is basically like we have a series of outcomes, and each of those outcomes has a particular probability tied to it. So right here, it's not, these are just sort of arbitrary numbers right now, but we're saying that the probability of x equaling 1 is 45%, a 0.45 chance. The probability that x equals 2 is a 0.2, a 20% chance. So like each outcome has its own particular probability, and if you added all of the possible outcomes up, that's 100% of the possible outcomes. So for instance, if there's a 45% chance of there being 1, 20% chance of 2, let's say we had all of this information except we didn't have what the probability of 4 was. Well, knowing that 1 through 4 are the only options you have, you basically add up the probabilities of 1, 2, and 3, see that, oh, I'm only at 95% right there. So what is the missing piece of the puzzle? Must be the extra 5%, that 0.05. So that's just sort of the nature of a discrete probability distribution. When we're dealing with cumulative, just think about what the word cumulative means. It means for something to accumulate, it builds on top of itself, right? So if we're going to turn this discrete probability distribution into cumulative, what we would do is say, okay, we have x equals 1 right here. That is a 45% chance that it is 1. But the thing is, this x right here, this p of x, it's really the p of x being less than or equal to these numbers right here. So it's basically p of x being 1. We can kind of illustrate it with this diagram right here. We have 1, and everything to the left of 1 is 45%. But look at when we get to number 2. See, this was under discrete a 0.2% chance of it being 2. Well, now when we're doing cumulative, the 2 is added onto what we already had. So to go from 0.45 to 0.65, it's an additional 0.2. So to illustrate that, we have the probability of x being less than or equal to 2 is 0.65, and it's the 2 and everything before it, including what was already in that 1. So you can see to get from 1 to 2 is an extra 0.2, which is where we have that discrete probability right there. So you can literally make synonymous in your head that cumulative means less than or equal to. So that'll be super important as we plug those into the Excel functions. You're going to have to really lock in your reference point, which we'll get to in just a second, as far as, okay, I'm finding a probability of a certain number. If I want that number and everything to the left, that's going to be cumulative. If I want just the probability of that number individually, it'll be point or discrete. So let's actually go ahead and get into a couple of examples of that right now. Okay, so knowing that we're dealing with discrete distributions here, there are two main types of distributions that we're going to talk about as far as our Excel functions are concerned, and the differences between them can seem a little bit subtle at first if you're working through certain homework problems, perhaps, that they'll tell you whether or not we're dealing with a binomial distribution or a Poisson distribution. Other times you might have to use some judgment, so let's kind of go over the definitions of them first. Essentially, the binomial and Poisson distributions are similar in that they're both discrete in nature, where we're going to have a certain outcome has a certain probability that's tied to that outcome. But the main difference is if there is a cap on the number of successes that you see in those distributions. So for example, an example of a binomial distribution would be if I'm flipping a coin. If I flip a coin 10 times, then I know I'm not going to get more than 10 heads or 10 tails. It's impossible for me to get more than 10 successes, whether I'm looking at heads or tails, since I'm only doing it 10 times. So it's kind of the nature of what you're looking at. If there is a cap on that amount, if it's impossible for it to be something beyond the number of times you run that trial, then that's going to be binomial. But when we're dealing with Poisson, there actually will not be a cap on the number of successes at all. So for instance, if I'm wondering the number of customers who come into a store every day, well, within reason, any number of customers are going to be able to come through my store. It's not like I'm limited by the nature of the trial, like where I'm flipping a coin, I flip it 10 times, I'm only going to get 10 outcomes. No, I'm counting numbers of customers who come in the door. So it's still discrete in nature in that I am counting individual customers, but at the same time, I'm not limited by the nature of it in that there's a cap on the number of successes I have. So that's kind of the main difference between the two. So once you identify that, you can actually calculate a lot of different probabilities based on these Excel functions right here. So for the binomial distribution, we have equals, and you just literally get a cell in Excel, type this in, fill in your information, and it'll spit the probability right out to you. We'll do a couple of examples after this too, so you can try it out on your own. But the Excel function itself is just equals, and you have to type in equals for it to open up the function at all. Binom.dist, and then it'll pop up a menu where you get to put in your number in question, which is really what you're locking in as your reference point. So if we're trying to find a probability about, I don't know, the number 4, most of the time 4 is going to be your number in question. There's a couple of situations where you have to be careful what you put right there, but we'll run pretty much through all of those in just a moment. N is going to be your number of trials, just how many things we're sampling in this particular sample. The probability, we have a particular probability given for that sample, and then 0 or 1 dealing with whether or not it's a point distribution or a cumulative distribution. So remember, cumulative literally means less than or equal to. So if the probability we're looking for is P of X is less than or equal to some number, you're going to fill in a 1 for this. If we're just trying to find the probability of a particular number, that would be the point distribution, so you just plug in a 0. So it's like a yes, no, point cumulative notation. And then the poisson.dist, once you identify it's a Poisson distribution, it's extremely similar, except the number in question comes first, just like here, but we're actually going to put the population mean here, and instead of needing a probability or anything like that, or N for that matter, we just put in the population mean, and then a 0 or 1 using the exact same logic, whether or not it's a point distribution or a cumulative. So let's actually get into a couple of examples. I think that's what's really going to best illustrate it. I'd recommend writing these functions down right here so you can kind of see how we plug into each of the parts of the equation. And once you're able to figure that out, it's like clockwork just going through each of those Excel formulas. So let's do that real quick. Okay, so in this situation, we have two probabilities that we're going to solve for. So we're already given in this problem that this is a binomial distribution. So remember from before, you can find out whether or not it's binomial or Poisson given certain considerations to the nature of the problem, whether or not there's a cap on the number of successes you could have. But sometimes you're just given the fact that this is a binomial distribution. So for here, we know we're going to use our binom.dist formula, which we put in, kind of our reference point, what like the number in question is, our N, which is our number in our sample, our number of trials, the P, which is the sample proportion, and then whether or not it's cumulative or non-cumulative based on what we're looking for. So if I'm asked, given this information here, what is P of X equals 4? Well, in this situation, I know it's binomial, so I plug in binom.dist. My reference point here, I'm wanting to know the probability of 4 itself. So really, 4 has got to be your number right there. There's not really any working around that to do. If it's a point distribution and we're wondering about the probability of a particular number, that is your number in question. From there, we know that N is 12, so you simply plug in 12. We know that P is 0.7, so you simply plug in 0.7. And here I'm going to put 0, which means point, instead of cumulative, which 1 would be cumulative. So I'm putting point right here because I'm wondering the probability of a particular value, of a point. So in that case, we're certainly going to use the point distribution, which ends up giving us, when you round it out, 0.0078. So you can practice plugging this into Excel, make sure you get the same thing. So as far as P of X being less than or equal to 4, it's actually the exact same thing. And one thing I would recommend with any of these problems, it's nice to map it out on a number line, sort of get an idea, a visual idea of what it is we're looking for, and then based on that, plug it into your Excel. So right here, we have 4, and I want what's less than and equal to 4, meaning 4 and everything before 4. So if that's the case, 4 is certainly my reference point. I plug in my 12, I plug in my 0.7, just like before, and then I'm going to say cumulative right here, because that literally means less than or equal to. So when I put in 1, Excel treats it like, okay, I'm going to find the probability of 4 in anything that led up to 4. So that means it's cumulative. When you do that, you end up getting about 0.0095. So try plugging that in. The next two examples are going to be a little bit trickier, but we'll clear it up in just a moment. Okay, so in this situation right here, instead of us dealing with P of X being less than or equal to 4, which made the calculation pretty easy because less than or equal to simply means cumulative, so we make it cumulative, make 4 our reference point, and it solves it right for us. Well, when we say that X is just simply less than 4, we're wondering about the probability of anything less than 4, but not including 4, like before. So when we're dealing with the cumulative probability, if this said equal to, 4 would be our reference point, because I want 4 in everything to the left. But the thing is, because we're dealing with a discrete distribution, we have sort of the numbers in between the numbers. And by that I mean, when we're talking about the difference between 3 and 4, as far as a discrete distribution is concerned, you're kind of treating it like counting numbers, like full whole numbers. So I'm not thinking about things like 3.1 and 3.2 and 3.3. So if I want what's less than 4, as far as a discrete distribution is concerned, it's actually going to be the counting number less than 4. That is the first thing that is less than 4. So 3 instead. So it's a little bit tricky because with discrete you have to understand if it's less than or equal to, it's just cumulative and you use the number they provide. If they just say less than, you have to make your reference point one number below what they're wondering about because that is the first number that's less than what we're looking for. So if I want p of x is less than 4, well, let me start with what is less than 4 at 3, and from 3 and back, that's what I want right there. That is what's going to give me my probability of x being less than 4. So instead of doing equals binom.dist 4, 12, 0.7, and 1, I'm actually going to do 3, 12, 0.7, and 1 because at that point, 3 and everything back is what is less than 4. So it ends up being approximately 0.0017. So be very careful with the less than versus the less than or equal to, because cumulative is less than or equal to. If it's just less than, and it's a discrete distribution specifically, go back one number, find everything from that point and back, and that's going to be your answer right there. So now here, one thing we have to also understand is that Excel is very limited as far as what functions we can use. Obviously, it helps in a lot of ways, like I can do probability of something being less than or equal to by doing the cumulative distribution, or I could find the probability of a particular number using the point distribution. But if I have a situation like this, where it's the probability of x being greater than or equal to 4, I don't have a function that's going to really give me a greater than mentality. So we have to work around Excel, and this is where a lot of us get tripped up just because it's not going to immediately spit out the answer to us. We have to work around exactly what the tools that we have to look for what we're looking for. So like I said before, let's go ahead and map it out on a number line so you see what we want versus what we don't want. What we want right here is 4 and everything above 4. So what is greater than or equal to 4? This is what I want right here. What I don't want and what I don't care about is 3 and anything before 3, because again, that's the first number that's less than 4. So I want 4 and everything above. I don't want 3 and everything before. So since my Excel doesn't allow me to find the greater than mentality, to find 4 and everything up, one thing I can keep in mind is, okay, this is a big probability distribution. I don't know exactly where it begins. I don't know where it ends. But what I do know is however big the distribution is, it is going to be 100%. Like the distribution is 100% of the distribution, right? So regardless of where it begins and ends, I know it's going to be 100% wherever that may be. So if I can find what I don't want and subtract it from 100%, the only other thing that's remaining is what I do want. So what we'll do right here instead is using what the tools that we do have, solve for the cumulative probability of 3 and back, and if I can remove that from the total of 100%, all that's left is the remaining portion, which is what I want. And so what we'll plug in Excel is equals 1 minus binom.dist, and what I'm solving for right here is 3 and everything before, and I'm doing everything before because it's 3, the 12, and the 0.7 like we're given that you just have to plug in, and then the 1, because if the 1 is cumulative, that's 3 and everything back. Take what I don't want out of the whole, it leaves you what you do want. So you can try that out, and we're going to do just one more example in case they're asking you for a probability of ranges, and that should sum up a lot of the tricky things that they could possibly ask you about in Excel. All right, so now in this situation, we can see it's a little bit different because the probability we're looking for isn't just the probability of something being greater than a particular number or less than a particular number or even that particular number itself. We're actually looking for a range of values right here. So there does exist a binom.dist.range formula you can use, but I don't want to harp on that too much right now because as we get into normal distributions and even if we're dealing with a Poisson distribution problem where we have a situation with a range of probabilities, you're going to want to go through it this way. There's not a dot range for those distributions. So this works just fine. It's perfectly intuitive based on what we just went over. So let's tackle how to do this problem real quick. So if I'm looking for the probability of everything between 2, including 2, and 4, and keep in mind we're dealing with a discrete distribution here, so you have to be careful about going one number below as your reference point and things like that. If we're going to map it out on a number line as far as what we want versus what we don't want, I want everything between 2 and 4, but I want to include the 2 right there, okay? So what I know that I don't want, I don't care about anything, 5 and up or 1 and back, but we don't really need to worry about the 5 right now, so let's just talk about the 1. 1 and back, I don't care about that at all. If it's less than 2, it's not included in my calculation because I want 2 and everything up to 4. Well, think about it like this. We have to work around the tools that we have at our disposal using Excel. So with Excel, I can solve for a cumulative probability, meaning it's that number and everything to the left. So think about it like this. If I'm finding the probability, the cumulative probability of 4, that will include the part that I'm looking for, right? Because I want from 4 to 2. So everything, for the probability of 4 and everything to the left of 4 includes what I want, but it also includes some stuff that I don't want, right? So the cumulative probability of 4 is going to contain part of my answer. So if I can just treat that as basically the 100% like we did before, that's the whole in question, and I can take the part I don't care about out of that whole, I'm left with the part that I do want. So let's see how we do that. Well, to find the cumulative probability of 4 and everything before 4, we'll just call that A for right now. A is just binom.dist. You put in your 4 as your reference point, your N, your P, 1 because it's 4 and everything to the left of 4, the less than or equal to, you get some number when you do that. So that's kind of the overall whole that you can think of. And then B is the part that I don't want. I don't care about 1 in anything before 1. So if I can do equals binom.dist 1, which is going to be right here, that's your reference point, 12, 0.7 from the original information, and 1, I will find 1 and everything before 1, which is the part of the whole I don't want. So I take the part that I don't want out of the whole, and it leaves me with what I do want, okay? So overall, it's just a matter of being able to plug this stuff into the formulas. I would say with discrete probabilities, the trickiest part is kind of looking at exactly what they're looking for, if it's a less than or equal, or an equal, so on and so forth, and how you need to plug that in, especially when it comes to your reference point. So essentially, if it's less than or equal to, go ahead and make the number that they're wondering about, P of x being less than or equal to 4. Use 4 as your reference point and make it 1 for cumulative, and that'll give it to you. But if it's just less than 4, not less than or equal to 4, you have to go 1 number back because we're talking about what isn't 4, everything before it. The first number before it is 3, so make that your reference point, everything back. So I hope that some of these examples give you kind of a good framework to use going forward. It'll really nicely help you out in our next video when we're dealing with normal distributions, and we actually have continuous probabilities with there. So it's going to be a little bit different, but this is an awesome foundation for you to go into that next video.